Hello, my name is Ashley Goodnight, and this is my Week 2 reading review for Physics 2212. In this week's EDX videos, we discussed three main topics: electric dipoles, interactions with neutral matter, and induced dipoles. Here I have a diagram representing a dipole. As you can see, the dipole has a positive and negative end. In the diagram, this dipole is affecting a particle at point O. Given information on the charge of the dipole and its distance from point O, we can find its electric field that it causes. We also learned about vector P, which represents the so-called dipole moment. There are two special cases we discussed this week regarding the orientation of the particle respective to the dipole. First, you can have the dipole on the perpendicular axis. This setup greatly simplifies the electric field equation. Similarly, in the other special case, having the dipole on the axis also simplifies calculations. Notice that the value for the dipole on the perpendicular axis is exactly half of the dipole on the parallel axis. The video on interactions with neutral matter was largely a vocabulary review for me. Ordinary matter with a net charge of 0 is called neutral. However, it may not remain neutral with polarization when the charges of the particle shift in the presence of an external electric field. Some vocab that was new to me was permanent and induced dipoles. Permanent dipoles have a dipole moment regardless of the presence of an external electric field. An easy example of a permanent dipole is a water molecule. Induced dipoles, on the other hand, only have a dipole moment when affected by an electric field. This dependence translates into its dipole moment calculations, adding an alpha variable. This stands for a polarizability constant, with units of Coulomb squared meter per Newton. This week's lessons apply directly to my major, electrical engineering. At Georgia Tech, EE majors select fields or threads to specialize in. Two in specific, telecommunications and circuit technology, have required courses that build off what we're learning in this class. Those who follow telecommunications take ECE 4350, electromagnetic and microwave applications, while students studying circuit technology take ECE 4391, electromagnetic compatibility. That wraps up my introduction to Week 2. Thank you for listening.